This is Team Operation Rebound-1, and our project is about easing the transfer of paraplegic patients in and out of wheelchairs. Emily, Sarah, Moini, Doria, and myself, Karen, will be presenting today. For the purpose of this presentation, I'm going to ask everyone watching to take a second to get up and stretch for a little bit. Now, I want you to think about how effortlessly you got up and out of that chair. Getting out of a chair is secondhand nature to most of us. Unfortunately, for some people like our friend Miguel at Operation Rebound and many other paraplegics, they don't have this luxury.
Approximately 65 million people worldwide have to use a wheelchair each day, and about 10% of these users have mobility issues with their chair. Here, we're talking about millions of people each day who struggle to get around in their wheelchairs. To add to this, about 1 in 3 users require assistance from another person in completing one or more daily activities. Our group will focus more specifically on easing the transfer of disabled patients in and out of their wheelchair, as the transfer can impose a high risk of falling and/or injury. The consequences of an inefficient transfer can include the need for a caretaker, a lack of independence which can severely hinder quality of life, and trouble completing daily tasks. We want to use our skill sets as BMEs to help the millions of people who have difficulties transferring in and out of their wheelchairs each day. From the identified problem, we formulated a unique needs statement that advertises a way to address the difficulty of paraplegic patient transfer in and out of standard wheelchairs in order to reduce the transfer time by 20% and increase the patient's independence.
Through Operation Rebound, we were given the opportunity to meet Miguel Martinez, and this is where the idea of this project began. Miguel Martinez is a paraplegic and is paralyzed from the chest down. Miguel is extremely active and has significant upper body strength, but during a meeting, he has expressed that he often falls while transferring in and out of his wheelchair. He also expressed us that while hoisting himself into his wheelchair, his clothes often get caught, which causes his transfer into the wheelchair much more difficult than it should be. Through research, we have found the current industry standard, the Indeed lift. This has been the only product we have seen with a similar concept, however, there are a few drawbacks to their design. First, it is extremely heavy, about 60 pounds, therefore is not portable and may not be easily used, especially with people lacking movement in their legs. This lift is also expensive, over $2,000 for the home use model. This is out of budget for many people, leading it to be not easily accessible to those that may need it. The Indie Lift also is marketed towards people who have fallen, aided in getting them back on their feet. This device, while it can help paraplegics, wasn't designed with them specifically in mind. Based off our meeting with Miguel and the research we have done, we have come up with a couple goals for this wheelchair transfer device. We first want the device to be portable. We are hoping to have it light enough and compact enough so that users can bring it with them wherever they may need to transfer out of their wheelchairs, and so it's not just a home device. We also want to make it cost efficient. We want it to be affordable so that it is in the budget of most, if not all, paraplegic patients that would benefit from this device.
The key design inputs we chose for the lift is that it had to be compact, so the dimensions have to be less than 42 by 80 inches when folded to allow for easy storage under the wheelchair. And it also has to withstand the body weight of an average male in the United States, which is around 200 pounds. And lastly, efficiency, so the setup and lifting process have to take less than 30 seconds. There are three main cost factors to this lift. The first one being the motor, which is around $60. This motor is similar to ones used for electric scooters. And the second factor is the scissor lift mechanism, which is around $20. And lastly, the fabric and plastic will cost around $10.
This is a diagram of our prototype, and we will now go into the decomposed subsystems. The switch control mechanism will enable the motor and battery to move the lifting mechanism up and down. Our key milestone is to successfully program the switch, and deliverables include understanding how to code a switch, programming the switch to control the lift, and testing its functionality. The motor and battery subsystem controls the mechanical movement of the scissor lifting mechanism. Our milestones include a battery with adequate power for multiple uses, and deliverables include researching motors that work well with scissor lifts, testing battery life of the motor, and creating a compartment for the motor and battery using CAD.
The scissor lifting mechanism of the device will move the patient and be controlled by the switch. Our key milestone for this system is for a device that moves at a constant velocity while withstanding the weight of the average patient. Deliverables include developing a physical prototype and testing velocity of the lift under pressure. Incorporating portable collapsible parts to our device will serve to stabilize the patient while the lift mechanism is engaged. Our key milestones for this subsystem are to have durable chest rest and handlebar components to increase the patient's comfort in transfer. Deliverables include testing various materials for optimal chest rest and utilizing CAD models for the system. We hope to make an impactful difference in the lives of paraplegic patients and our friend Miguel with our device. Thank you so much for your time.